Okay, welcome back to my channel. So in this video we'll be talking about the limit of a function. Okay, so we'll be solving some questions from my workbook. So the first question we'll be solving is question number 40. So question number 40 from my workbook said that we should find the limit as x approaches 3 of x raised to power 4 minus 81. Okay, now divided by x minus 3. Now limit is the easiest question you should solve. In fact, in your exam, once you get the paper, look for limit. It's very simple. Okay, that's the easiest question. Now the first thing you do in limit simply means just substitute what you're having here. He said x should be equal to 3, but that's not how we call it. We call it s tends to 3 anyways, but just substitute that s is equal to 3. And if you watch out, if I substitute that s is equal to 3, let's do that. If x is equal to 3, we'll be having 3 raised to power 4 minus 81 all over 3 minus 3. So 3 raised to power 4 is what? 81 minus 81 all over 3 minus 3, which is what? 0 over 0. Now, the problem is, whenever you get 0 over 0, you have to differentiate. But if you get 0 over any number at all, let me say any number, please do not differentiate. 0 over any number is 0, while any number over 0 is what? Infinity. Please, but the only time we differentiate if it is 0 over 0. Some people will just get 0 here and then they want to start differentiating. Please don't differentiate. So, but if you did not, if once you get 0 over 0, like I did here, I have to differentiate. So this is going to be the limit as x approaches 3 of x raised to power. Now, normally, this is differentiation of quotient rule, but we are not using quotient rule here. You know, anything in fraction is quotient. We are not using quotient rule. In limits, everybody is on your own. So differentiate this person on your own. Differentiate this person on your own. Differentiate on your own. Everybody on your own. So let's go. Differentiation of x raised to power 4. Don't forget that differentiation simply means multiply by the power, remove 1 from the power. So if you multiply by the power, I'm going to have 4x. If I remove 1 from the power, I'm going to have raised to power 3. Okay? Differentiation of a constant, anybody that does not have x is 0. So this one is gone. Divided by differentiation of x is the coefficient, which is 1. Differentiation of this one is 0, is gone. So anything divided by this is the same thing. So I'm having that this is the limit as x approaches 3 of just x raised to power what? 3. And then we can now substitute again, which is 4 in bracket of 3 raised to power 3, which will give you 4 in bracket of 27, which will give you, I think, 108. Okay, so that is that. So let's do that. 4 times 27, 108. Okay, so now this is the first method and the easiest method you can use. Let me show you the second method in case you want to use it, but it doesn't really work out all the time anyway, but this is the perfect one that works out all the time. So this one is that the limit of alternatively so alternatively, I'll have the limit as x approaches 3 of x raised to power 4 minus 81 all over x minus 3. Okay, now is equal to the limit as x approaches 3. Now, if you look at this one now can factorize. Do you know that this is something as saying x raised to power 2 all squared minus 9 squared, then all over x minus 3. Do you believe me? Now, this is difference of 2 square. So this is step now saying the limit as x approaches 3. Some people are already giving up. Once I started doing something like this, some people are already giving up. They say, I prefer this one. I know that will be in some people's mind, but it's not difficult to know. So this minus the difference of 2 squares said x squared minus 9 and another x squared plus 9. Okay, then all over x minus 3. Now, if you look at this one again, this one is another difference of 2 squared, but let me show you. This is now the limit of as x approaches 3 of, now this is something as saying x raised to power 2 minus 3 raised to power 2. I seen that. Then in bracket of x squared plus 9, then all over x minus 3. Okay, now this is difference of 2 squared, so let us do that. This is now the limit as x approaches 3 of, this is something as saying x minus 3 and x plus 3. That's the meaning of this one. Then keep your x squared plus 9 here, all over x minus 3. So what do? This can now take care of this. So I'm now left with the limit as x approaches 3 of x plus 3 in bracket of x squared plus 9. So we can now substitute. If we substitute, I'm going to have, that is 3 plus 3 in bracket of 3 squared plus 9, okay, which is 3 plus 3 will give us 6 in bracket of 9 plus 9 is 18. So 6 times 18, what do you have? 18 times 6, 108. So 108. Okay, the same answer. So which one do you prefer? Tell us in the comment section. Which one do you prefer? Do you prefer this factorization? You have to factorize up. Even if down is factorizable, equally factorize it, and then something will cancel out. That's just the simple method. So to me, I prefer this one. But I know you will prefer this one. But tell us what the one you prefer. If you prefer the two, still tell us at the comment section. Okay? So that's the first one. The second question in limit we are going to solve. The second question in limit we are going to solve is question number 66. Question number 66. So question number 66 said the limit as x approaches infinity, of x raised to power 2 all over x minus 7 all squared, then minus 6. Now, please, anytime limit approaches infinity, the shortest cut to your answer is just the coefficient of the highest power everywhere. To me, if I want to solve this, the highest power in the numerator is 2. The coefficient is 1, so I'm taking 1 all over. If I clear here, the highest power again is 2, and the coefficient is going to give me must be 1. So the answer here is 1 divided by 1, which is 1. Very simple. This condition is used only when x tends to infinity. Please, if it is not infinity, don't use this thing I said now. It must be infinity. It must be infinity. So, but let me show you how to solve it normally. Let's solve it normally. So this is helping us saying the limit as x approaches infinity of x raised to power 2 all over. To clear this place is square the first one, x squared. Multiply this to double it, minus 14x. Square the last one, plus 49. Then bring down your minus 6. So this is now the limit as x approaches infinity of x raised to power 2 divided by x raised to power 2 minus 14. Now, these two people will give me plus 43, right? Now, what do? Whenever it is 10 to infinity, we divide everybody by the highest power. So we say the limit as x approaches infinity of, let's divide, x raised to power 2 divided by x raised to power 2 all over x raised to power 2 divided by x raised to power 2 minus 14x divided by x raised to power 2 plus 43 divided by x raised to power 2. Okay, so we close. So this is now the limit as x approaches infinity of, this is now 1 over 1 minus 14 over x, okay, plus 43 over x squared. Now, after dividing, before we substitute infinity. So if we substitute infinity, I'm having 1 over 1 minus 14 over infinity plus 43 over what? Infinity squared. Okay? So what do we have now? This is now 1 over 1 minus 0 minus 0, because anything divided by infinity is 0. Okay? So which is giving me 1 over 1, which is what? 1. So instead of taking all these long processes, if it is an objective question, what we simply do is what? Take the coefficient of the highest power, 1. If you factorize this one, the highest power is going to be x squared, like I factorize here. So the highest power, the coefficient is equally 1. So 1 divided by 1 is 1. So that is just it. Just take their coefficient. Okay? So we go to the next question. That is question number. So we move to question number what? 72. Question number 72. So question number 72 said the limit the limit as limit of x raised to power this 81 all over x squared minus 9, and then x approaches number what am I solving? Okay, minus 3. Okay, so the first thing is to substitute. So let us substitute. Solution: if we substitute, we are going to have minus 3 raised to power 4 minus 81 all over minus 3 raised to power 2 minus 9. So if you look at this, I'm going to have 81 minus 81 all over 9 minus 9, which is what? 0 over 0. And I told you, once you get 0 over 0, we must differentiate. So which means I have the limit of x raised to power 4 minus 81 all over x raised to power 2 minus 9, and as x approaches minus 3. So if I differentiate, it's going to be the limit as x approaches minus 3 of multiply by the power, remove 1 from the power, which is 4x raised to power 3. Differentiation of this is 0 all over multiply by the power, remove 1 from the power, which will give you what? 2x. Okay, so this is now the same thing as what? The limit as x approaches minus 3 of something can cancel out. This divided by this will give you 2x squared, right? 2x squared. 2 divided by this is 2, divided by this is x squared. So I can now substitute to have the limit as x approaches minus 3 of 2 in bracket of minus 3 squared, which will give you 2 in bracket of 9, which is what? 18. So that's the first step. Alternatively, what do? We factorize like I taught you before. So I'll say the limit. If you don't like this method, let's use the factorization method as it approaches this of what? X raised to power 4 minus 81 all over x raised to power 2 minus 9. So like I told you, this is the same thing as saying the limit as x approaches minus 3 of x squared all squared minus 9 squared, then all over x squared minus 9. So the numerator is difference of 2 squares. So this is the same as what? The limit as x approaches minus 3 of x squared minus 9 and x squared plus 9. Okay, then divided by the same x squared minus 9. See, this can cancel this. So I am left with the limit as x approaches minus 3 of x squared plus 9, which now we can now substitute, which is what? Minus 3 all squared plus 9, which will give what? 9 plus 9, which is what? 18. The same answer. So which of the method do you prefer? Do you prefer the differentiation method? This method I use here is what we call L'Hospital's rule. L'Hospital's rule is this method of differentiation. That's what it is called. Okay, but the name is not really necessary for you. Just know how to solve it. Yeah, but if you want to know the name, no problem. So this one is just the factorization method. So the next one is question number 97, or question number 90 first before 97. And the last question is going to be that question number 97. So question number 90 first. So question number 90. All right. So question number 90 said, oh, this one approaches infinity as well. So the limit as x approaches infinity. This one is one I love very well because it's not stressful. Of 3x squared plus 2x plus 1. Anytime limit approaches infinity is what I love. 2x squared minus 1. Okay, you see the answer here obviously is 3 over 2. Yes, because the highest power is squared, the coefficient is 3. I will take it over. The highest power is equally squared again, the coefficient is 2. I'm taking it. So 3 over 2. But let me show you how to solve it in case you have theory question. Okay, so solution: what do we do again? We divide everybody by the highest power before we substitute limits. Okay, so this is now the limit as x approaches infinity of 3x squared over x squared. The highest power variable here is x squared. So minus 2x over x squared plus 1 over x squared all over 2x squared over x squared minus 1 over x squared. So this is now the limit as x approaches infinity of 3 here. This has cancelled this. Minus 2 over x, then plus 1 over x squared. Then all over, this is 2 here, minus 1 over x squared. So let us substitute infinity. So I'm going to have 3 minus 2 over infinity plus 1 over infinity squared. Then all over 2 minus 1 over infinity squared. Like I told you, anything divided by infinity is 0. So I'm having 3 minus 0 plus 0 all over 2 minus 0. So you see, my last answer becomes 3 over 2. Very simple to solve. So the next and the last question to solve is question number 97. The next and the last question to solve is question number 97. So question number 97 now said, question number 97 said, where is 97? Okay, question number 97 said that the limit as x approaches infinity again of the square root of x raised to the power 4 minus 81 all over x raised to the power 2 minus 9. Okay, so like I told you that the answer here is simply 1. That is 1 over 1, which is 1, because the highest power here is 4. The quotient is 1, pick 1. Highest power here is 2. The quotient is 1, pick 1. So 1 over 1 is 1. But let me still show you how to solve it. So learn how to solve it. Normal method. Divide by the highest power before you substitute infinity. So we say the limit as x approaches infinity of the square root of x raised to the power 4 divided by x raised to the power 4. Then minus 81 divided by x raised to the power 4 all over x raised to the power 2 divided by x raised to the power 2 minus 9 divided by x raised to the power 2. So this is now the limit as x approaches infinity of the square root of anything divided by this is 1 minus 81 over x raised to the power 4, then divided by 1 minus 9 over x squared. So if we substitute infinity, I'm going to have the square root of 1 minus 81 over infinity raised to the power 4 all over. Okay, this place is too small, so let me write it here. So this will give us the square root of 1 minus 81 over infinity raised to the power 4 all over 1 minus 9 over infinity squared. So if you do that, you have the square root of 1 minus 0 all over 1 minus 0, which is 1 over 1, which is 1, because anything divided by infinity is 0. So here is 0, here is 0. The same answer. So the easiest method is just for you to take the quotient of the highest power divided by the quotient of the highest power. You get your answer. So may the peace of the Lord be with you. In fact, the way this is supposed to be is the square root of 1 here. Please don't forget this square root, then divided by 1, which will give you 1 over 1, which is still 1, so that you will not be confused if there is square roots in your own. Okay? So thank you very much for watching. Please share to your friends. Subscribe if you are new to this channel. If you have not subscribed before, like this video and comment. May the peace of the Lord be with you.